actually, yes, I understood that. What I'm trying to do is to inspire you a bit, and by telling you about all the kind of things that phonetics can do, not just prosody, but basically phonetics. Because I guess when you studied, or perhaps when you are still studying, what I heard in those days was, "What are you studying? And what can you do with this after that?" And I found this so unfair, because people who are studying law or medicine, they're never asked, what can you do with that after that? So I think it's also part of our mission as those people who are giving lectures, basically, to encourage students and young scientists that they're actually doing something very, very useful. The talk today is meant to underscore that, in a way, to stress that kind of message. And I will share the slide deck with you. I hope that you can see it. Yes, at least, yeah. Wait, it's still, yeah. Do you see the full screen, or do you see something else? The full screen. Super. Okay, thanks, Anne. Yeah, so basically, how how the speech sciences can be useful in life. This is the title, and it's basically about ideas or that we have already successfully done in connection with applying phonetics to the world, basically. But I will start with a little bit of an introduction that picks you up, hopefully, with the strong statement that speech is basically something special. Oh, I just see that my internet connection is unstable, but I hope it's gonna be okay. If it's not working, let me know, because I'm just like Claudia. I'm in hotel Wi-Fi, and I'm not sure how stable the connection actually is. So I'm in Technical University Berlin, to be precise. I'm not even in Denmark. And the reason my speech is special, there are several reasons. One of the reasons is that there is still, to date, no other signal that we are subjected to in our everyday life as often as speech. So there are statistics, for example, about the types of auditory input that we get during the day. There is basically music, and there is traffic noise, and there is silence. Silence being less than about 5% nowadays. So silence has become very, very rare. And also speech. And speech still is still in percentage the most heard signal that we are subjected to during the day. So this is basically one of the things that that makes speech special. So we basically get out of bed, and we are somewhere listening to speech, be it on the radio, be it in our house or on our flat. And when we go to bed, we are still, or at least before that, we have still listened to speech, be it latest news or whatever. Speech is everywhere. And the second thing is that speech is basically, we have basically co-evolved with speech. So the human evolution, I'm simplifying here a bit, yes, but in a way, the human evolution and speech evolution have somehow co-evolved. Our speech has tailored itself such that it fits with our auditory perception capacities and cognitive abilities, and they, at least this is claimed by some scholars, and they have also developed such that they accommodate for speech signals, not just in speech production, for example, categorical things or acoustic quantization, but also other things in the way our cognitive mechanisms work. So their speech and us as human beings are somehow very closely connected. What we see here, for example, is an example of the auditory threshold and the area where we are most sensitive to in our perception is basically the area in which speech takes place, at least in which the meaning that we convey through speech takes mainly place. And the other example that you see here on the right-hand side is how the different vowel systems develop, and they have developed such that they maximize acoustic distinctivity, so that the vowels that we use also at the phonetic level and not just at the phonological level are somehow designed such that we are maximizing contrasts. Not in all respects, not in all contexts, of course, but in general, there is the tendency of meaningful contrasts to be acoustically distinct from each other. And third thing that makes speech special is that speech is not just an instrument, basically. Especially the engineers, but not only the engineers, tend to think of speech as a tool that conveys propositional meaning. So we get information from A to B. But this is basically perhaps not even primarily the main reason why we are communicating. We are basically communicating for social reasons. We are social beings, we are socializing, and we are talking even if we have nothing to say, or at least if we have not spectacular information to get across. People are talking to each other as a social activity. And I think that sometimes we tend to underestimate that. And there are some indications why this is true. For example, that we change our speech production when it is noisy around us, but we change it even more. So this kind of tendency to change gets stronger and also more pronounced multiparametrically if we actually have someone to talk to. So basically, speech and noise, when there is nobody to talk to, is different from speech and noise when we have somebody to address. Another thing that actually shows this is that we are also talking differently if our audience is just virtually. So even if we are just in the virtual reality, we are trying to speak in a way that we get a message across, so that we are communicating with someone. We're not talking for the sake of talking, but we are talking for the sake of communicating, so of being with other people. This is something I think that is important to know. So speech is not just an instrument, as a tool, as a mere mechanical thing. Speech is something entirely social, and a way that we have it the entire day, and that is co-evolved with us. And perhaps all that applies even more so to prosody. Perhaps also because prosody is our oldest means of communication in a way. So the kind of grunts and the kind of voice and non-verbal meanings are probably older than words and syntax. And there are interesting things that show that. For example, that we can train an artificial intelligence, or something like an algorithm at least, to predict if we are still together, or how the relationship is within couples. We can see how relationships are between people from the way they talk. And one of the most spectacular studies or projects in this respect was on BBC a couple of years ago already, 2019, where an artificial intelligence has learned to pick up on these kind of prosodic signals to predict whether our relationship will last. So in a way, the AI was able to predict within I think with an accuracy of about one or two weeks, if a couple splits up or stays together after something like a pair therapy, for instance. And there are also other things like, for example, prosodic entrainment. And please don't ask me why this has been investigated, but it has been investigated that male and female mosquitoes actually entrain their pitch level to each other when they signal that they are basically ready for pairing up. And we do the same. So basically, the way we signal that we actually like each other also at a romantic level is still similar to what mosquitoes do when they like each other. So this is just an example to show you that prosodic patterns or prosodic meanings, let's say, can even be shared by other species. And that's quite extraordinary, I would say. And yeah, prosody is so special that we can also detect whether or not people are actually telling the truth. There is, of course, quite well-known research from Julia Hirschberg and her team. They have done lots and lots of studies on that, and they are still working on something like trust, for instance, nowadays. One of the things that they showed is that you can tell with up to about 70% if people are telling the truth or not, and that human raters are performing also above chance level, just as machines can do it. And what we did in 2016 was that we have tried to predict the correct answer from the Who Wants to Be a Millionaire setting. And it was possible. So in our setting, in our experimental setting, we were able to predict with up to 80% which of the answers from the moderator which was actually the correct one, provided, this is the important thing, provided that that the moderator, him or herself, knows the correct answer. Because in this case, you see an increase in stress level, and the increase in stress level just immediately reflects in the voice. And that allows us to predict. And the funny thing about this is that the further you get in the quiz show, so basically the more money is at stake, the easier it becomes to predict which answer is correct, because the higher is also the stress level of the moderator in that case. And what I also said last week, basically beginning of the month, 1st of March, I think was our first session. But I can repeat this here again, is that we can also predict not just from prosody, but from the body language and prosody in combination with a stunning accuracy of 70 to 80%, whether or not investors get convinced, business cards get exchanged, clients get acquired, and whether in a speed dating scenario, the fake telephone numbers or the actual real telephone numbers are exchanged. So basically just based on prosody and on what people gesture, perhaps, yeah, we decide whether we actually want to know more about that person or not. And this, I think, makes it quite powerful in social interaction. And what I also showed last time, I think, but it's still worth being repeated, the study from my Danish colleagues, Uffe Schött and colleagues, what they did was basically they showed that if you put Christian believers into a magnetic resonance tomography, so an MRT or fMRI system, and they only listen to more or less charismatic preachers preaching. For the more charismatic preachers, people's brain activity decreases in at least in some areas of the brain that are related to cognitive control of behavior and abstract reasoning. So to areas that made us critically reflect upon things that do inhibit our own action potential. So we are basically saying, yes, I'm going to buy that, or yes, I believe that, or yes, I'm going to sign that paper if people are very charismatic. So, and this is only the voice. So the voice has an is able to affect the brain functionalities at some very basic level that then decides how our further actions and opinions are shaped. And what I've not shown last time, I think, is this one here, that we can actually also train artificial intelligence algorithms to predict from especially the speech acoustics outcomes that are present in the real world. So in this case here, in this study, they looked into consumer relationships and consumer buying behavior. So it was a cosmetics sales client interaction, and the question was, is this cosmetic product sold to the client or not? And what they had available was the acoustic signal of both the client and the consultant, and the linguistic signal, which is basically the text. And as you can see down here, they have what we have here are the prediction performances of the machine predicting the correct outcome. So the product was either sold or was not sold, and the machine predicted this outcome. Based on the acoustics, in this case, it gets an A, and the linguistics was the L. And interesting here is that, first of all, the acoustics outperforms the linguistics. So the acoustics outperforms the text. The machine is less well able to predict from the text alone whether or not the product gets sold. It is much better able to predict from the acoustics whether or not the product gets sold. And what is also interesting is that this information is contained in the consultant and the client. So both the client's voice or the client's acoustics and the consultant's acoustics both predict whether or not things get sold. I think this is quite interesting. And so if we look into artificial intelligence studies, actually many of them test that it is the audio signal, or perhaps more specifically, it is the prosody that actually makes the difference. In Niebuhr and Scherer, it was about the success of debaters to sway votes in political elections. And here it was also the audio that performed better than both the video and the text. In Petkova and colleagues, it was the persuasiveness rating prediction. So how good the speaker performed in terms of persuasive speech. And here we also see that the prosody was more powerful in this prediction than the hand motion. Of course, motion and prosody together were basically even more powerful. And in Turner et al. Was the public speaker assessment prediction. And also there, the speech was more powerful than both the visual and the lexical information. So basically, prosody can do a lot. This is one of the two main messages that I want to convey today. And the other main message is that given this importance of speech prosody or speech acoustics in our life, given how much it determines our decisions, our actions, our consumption behavior, our thoughts, our votes, I have sometimes the impression that phonetics or speech sciences are drastically underestimated, but also when it comes to funding, eventually also when it comes to funding. So if we look into what is actually hip and in and on vogue, then we have, yes, I just said that, then we have, on the one hand, we have the speech sciences. This is at least how it is currently done. And on the other hand, we have things like artificial intelligence, biotechnology, robotics, genetics, astrophysics, perhaps also nano or solar technology, all this kind of stuff. And this is all more important in the eyes and ears of the people out there. But I'm actually not sure whether this is true. So in my opinion, at least, there's a little bit of a balance, or perhaps even the speech sciences count as much as all of the other fields that you see that are more buzzy on the right side of this balance here. So yes, I would think that we can actually try to exchange that in the way we are talking about our discipline, in the way we are selling our results to the public. I think this is something quite important. And as you will see, I have some examples now from our research where we can see that we can actually make a lot of things from the speech sciences. So basically the question, what can you do with this after your studies, I think has actually a number of exciting answers to it. And I want to give you some inspiration for that here. Yes, okay. So I'm at SDU. I'm also leading the acoustic in production unit. So basically, I'm the head of the acoustics lab. And in this lab, we have a team of interdisciplinary researchers that is called Acoustics in Production. And what we try to achieve is we want to have an applied and highly interdisciplinary, closely connected research inspired by the speech sciences, and then reaching out to business and to the engineering fields, where we put speech into the center of all of our research and development activities. So basically stating that that a signal that to which we are so accustomed and so used, and also that we are cognitively giving so much priority, we can actually learn a lot from this specific signal for many applications and for many other fields of development. This is what we want to achieve in our team at SDU Sonneborg. The applications is, for instance, pain quantization. So we have collaborated in the past. It's already 3 years ago, I think. It's about 3 years ago, yes, where we had a project together with an insurance company in Germany. And this insurance company wanted to basically approached us and asked us to develop a new way of quantifying pain, because pain is sometimes difficult to quantify. For example, if you have people who cannot express themselves properly, small children, people suffering from dementia, or perhaps even people speaking other languages that come to the hospital and are not able to express themselves. So how can you assess the pain level in this case? And then the other, let's say, for the insurance company, the most important argument was, of course, always about money. And in this case, it was about how can we identify fake pain from actual pain, because people come to the doctor just because they don't want to go to work, and they say, "Oh, I have such a bad backache, so I cannot really go to work today. I need 1 week free at home, please." And then it's, of course, the question: is it actually true or not? Right? This was, for this special insurance company, the main reason also to support our research financially. So these were the kind of applications that we had to look at, and we did several experiments. One of them was with sustained vowels, and it was in collaboration with people in Bamberg, at Bamberg University there, in the psychology, if I remember correctly. And what we collected was, first of all, sustained vowels, and we have created pain in terms of heat. So people got a little, device basically attached to their hand, and they had to hold it, and this actually got hot. And we had people, and we've asked people to vocalize while basically heating it up. And there was also a cooling condition. So one was heat, one was cold. and we have asked people to vocalize. And what you have down here are the temperature levels, for example, in relation to people's pitch levels, so fundamental frequency during the vowels. And as you can see, especially when it's getting really hot, so when the pain gets high, then people's pitch level goes up. And for some vowels, actually, for some vowels that are even more pain related, this shows up more clearly. So for example, a schwa, like you wouldn't do a schwa-like vowel if you have pain, but perhaps an oo is something that you would perhaps do more intuitively. And in this case, even this kind of vowel qualities are more sensitive to pain-induced prosodic changes than the other vowels, but they're not so typically pain-related vowels. And we also looked into single sentence utterances, and then we see speaking rate increases, speech reduction rate decreases, especially for consonants, but it increases for vowels, that we see a delay of pitch accent peaks, that we see reduced final lengthening. All of these kind of things happen when people's pain levels go up. And the interesting thing is that these parameter changes are closely related to the they are basically all correlated in a way to the pain level. And because this is such a complex pattern of prosodic changes, it is hardly impossible to fake. So we have also tried that, and based off a discriminant analysis and based on people's pain levels or pain vocalization patterns, we were able to discriminate pain from not pain in about more than 95% of the cases. We were actually correct with that. So it is a high prediction rate of people have pain or do not have pain, especially at the high pain levels. And the pattern is so complex that we can say, well, it is basically fake proof in a way. So this is basically one of the applications where you can use prosody to do something useful in a real life application, pain estimation. The other one that we have done in the last couple of years was the so-called Karen project, Communicative Approaches to Reducing Industry Noise, where we looked into what is actually industry noise and how harmful, how stressful is industry noise. And we did this for a number of different noises, for machine noises, for robot noises, for actuator noises, for car noises, or basically traffic noises in general. And the idea of this project was, and we haven't actually made it that far, unfortunately, but it is still the idea, let's say. We aren't really there yet, but to build something like an innovative, a new way of measuring noise based on how people talk. So we use people's speech changes to estimate how annoying, how stressful a noise signal actually is. This is the idea, and I think that we can actually get there. So the idea is not only to rely on decibels, because noise is actually a lot more than decibels, and to use behavior, more specifically speech behavior, as a new metrics for noise assessment. And what is interesting, or what actually makes us optimistic that we can do that, is that what you have here is the correlation between the annoyance level of noise and the subjective interference of this noise with people's speech communication. So these are basically two dimensions of ratings that you see here, but we have also taken them, of course, independently from each other. So these are this has been rated independently of each other. So in one case, people rated how how annoying is this noise? And in a second case, where people have been in a dialogue situation, they have rated how much does this noise interfere with our current dialogue speech communication. And as you can see, there's actually quite a bit of a correlation. So basically, the more people feel disturbed by a certain noise, the more the more people also rate this noise as being stressful, as being annoying. And I think this is quite interesting and quite insightful. What we also found is that the more rhythmical and the more variable a noise is, the worse it is actually rated in terms of its annoying. The more a noise interferes with the long-term average spectrum of speech, the worse it is rated, and that the absolute dB levels correlate less strongly with these two ratings of annoyance and interference than the actual speech behavior. So this is actually, I think, and this is a good starting point, let's say, for trying to use speech as a diagnostics for noise-induced stress, let's say. And we have pushed this even further in another experiment that we have published in a paper at the Internoise conference, where we have manipulated noise artificially. So where we have basically taken a constant white noise signal. So basically white noise means that you have noise level at a constant amplitude across the entire spectrum. And what we did is we have changed this spectrum in that we have taken out certain things of the spectrum. So we have taken noise, we have basically put acoustic filters to 1 kilohertz, 2, 4, 6, and 8 kilohertz. And we have played this noise to people of different languages. And the reason why we did that is the observation that different languages use different parts of the acoustic frequency spectrum to different degrees. So if you would take the frequency range from 1 to 10,000 hertz, you would see that, for example, Chinese language, so tone languages in general, that don't have that many consonants, use a lot more of the lower spectrum, of the lower frequency spectrum. So especially below 3 kilohertz, there's a lot of frequency energy used by speech, for example, in the Mandarin Chinese. And if we go to German, we see that German has basically in about 2 and 4 kilohertz, there's a lot of spectral energy in the German language. And if we go further up, for example, for Czech, where we have a lot of consonants, a lot of obstruent consonants that have high frequency energy, we see that especially for Czech languages that we have in the range of 4 kilohertz and 8 kilohertz, a lot of frequency energy present. So languages make different use of the available acoustic frequencies. And now the interesting finding is, if you play people of these languages these acoustic noises and you ask them to rate how stressful, how annoying is this noise for you, then you actually get different responses from these different language people, and they are matching with how much this specific language occupies these frequencies where the noise is in. So an example, when we take the 1 kilohertz region, where we have a lot of energy used in the Chinese language, and it is the mean level of noise annoyance here. Then we see, so basically, I must say to be clear that that lower actually means worse. So the lower the scale, the worse the noise is perceived. So this is, I think, important to clarify. So if we are looking at this, we see that Chinese people think noise at about 1 kilohertz as extremely annoying, and German people as not so much annoying, actually. And this actually matches with the fact that for the Chinese people, at 1 kilohertz, there's a lot of information used by language in this 1 kilohertz region, but not so much by the German language. And if we put this around, we see that for the Czech and for the German language, at 4 kilohertz, people think that this is very, very strongly annoying noise, but not so much for the Chinese listeners who don't use this kind of frequency region that much for communication. And the interesting thing here is that people say this even if they are not talking. So people have this impression even when they are not actively talking. And this is an interesting thing, I guess, as well. So what we did in connection with this kind of Karen project, and we are currently implementing parts of this idea already in terms of jet turbine-driven road dryer, fine-tunement, actuator-driven sound design, and also Industry 4.0 robotics lab. So we are basically noise designing industry applications based on speech. So we are advising people, well, if you are selling your product in China, make sure to change the noise emission such that blah, blah, blah. Or if you are going to the US as a Chinese company, make sure that you are noise designing your device in a different way. And basically, it is the speech sciences tell us how to do it. So speech sciences can be useful in something like industrial design. And also one more thing that I've mentioned, the number 3 of my examples is basically what I showed last time, namely people's assessment of speaker traits, like, for example, charisma or trustworthiness, persuasiveness, self-confidence. What we did here in this case is we have determined for each prosodic parameter what is actually a good thing. So what is perceived by people as being good, the so-called sweet spot for each of the differences, like tempo, pitch level, pitch range, pause duration, pause frequency, loudness variation, and loudness level, things like this. And then we have put each of these parameters even into something like a ranking. So we have also determined experimentally how important is loudness level, how important is pitch level, how important is pitch range when it comes to perceiving a speaker as being charismatic. So we have done all that, and we have combined that in our research to what we call acoustic voice profiling. And we are now commercializing this actually more and more. In terms of the lab income, acoustic voice profiling is becoming a real substantial pillar, I must say. So we are taking people's speech samples. We are asking people to upload a voice sample to our system. We are breaking it down into the charisma parameters, the prosodic parameters that are also relevant for charismatic speech, and we give people a score because people like scores. People like to get an assessment in terms of a number, but actually the real arts behind it is basically what you see here in the middle, that we know for each parameter how well people perform, and that we can train people individually and specifically and objectively based on these specific parameters. And we are selling this kind of thing. For example, last year, we had a lot of different customers. And we are also developing further. So we are developing software, hardware, VR applications. We are reaching out also in terms of the acoustic body size and how strongly people or how clearly people articulate. We can actually measure more and more of people's performance on stage. Yeah, so this is something that is interesting. And also, what we are actually measuring there in terms of the score, I think I've showed this also beginning of the month, but I will just briefly repeat it. In terms of the score, we are actually measuring something that seems to have some kind of reality to it. For example, each first semester course in electrical engineering in our university is a little team building exercise that is called the Marshmallow Challenge. There are always teams of students who have to build a tower of spaghetti. So they get spaghetti, they get sticky tape, they get a little band, and they get a marshmallow. And they have to, only based on these things, they get about 20 minutes time to build a tower. And when the time is up, they have to put the marshmallow on top, and the tower has to stand for 60 seconds without breaking down. And if the tower remains, then we are actually measuring the height of the tower, and the highest tower wins every semester. This is always a big fun and a playful thing. But if on top of this, if we look into the group's average charisma score that we can measure from the way people interact inside the group, and if we connect this to the height of the tower, so basically how successful are people in this team working exercise of the Marshmallow Challenge, then we see that there's a positive correlation. So the more charismatic people interact inside the group, the more successful is basically the output of the entire group. That's something that we see basically for each year. This was the clearest year, to be honest, and 2021 or 2020 was the clearest year in this respect. But each year has a certain correlation like this. We can actually also predict companies' performances. So what we also tried out is if our Pascal score, if we are measuring the CEO's annual speech, so the annual stakeholder speech of the CEOs of the German stock index 40 companies. If we measure this particular charisma score, can we predict the company's dividend distribution from this year of which we have measured the score? And yes, to some degree, there's also a positive correlation about the more charismatic CEOs are in the companies that actually are able to give more money out to their shareholders. So basically, as a long-term success measurement, we see that company success and CEO charisma, in the way we are just measuring it from the acoustics, is something useful. And we put it even further by seeing, for example, that we see a negative correlation between psychopathy self-assessment in the US and our scores. So basically, the more psychopathic people think the charismatic they are, the less charismatic they actually behave acoustically. So there's a correlation between psychopathy and acoustic charisma, but it is a negative one, interestingly. And what I've not shown here, but we also interesting to note, is that we can we cannot just measure our Danish students' group exercise success, but also actually the oral exam grades of Danish students based on our scoring system. yeah, well, I think I can skip this one here. It is just to, no, I'm just do it quickly. So just one more thing that I've not mentioned last time, but this is worth mentioning, is that we have also tested our scores in creativity workshops. So in actual workshops where people interact, and one of them was the so-called egg drop contest. That means that people get 1 hour and they get the exercise of, you have different materials on your desk and you've got an egg. Please try to package the egg in such a case that if you basically throw it from a 5 meters high bridge to the ground, that it does not drop. That it does not break. Of course it will drop, but it does not break. So this was the exercise. It should not break when you drop it from the bridge. And we have created 2 different video moderated conditions by the same person speaking the same text, but once in a normal matter of fact fashion, and the other time in a more charismatically performance fashion. And as I said, the same person, the same text, the same creativity task. So the only thing that differed was the speaker's prosody between these 2 creativity workshop conditions. And what we saw was amazing, and this was especially amazing because the workshop was just one. Was basically 60 minutes, was a full hour, but the workshop moderation videos in total were only 8.5 minutes. So basically less than 10 minutes within this 1 hour was our stimulus in this task. And even though it was just 8.5 minutes, we see a huge difference in how the groups behaved. In the charismatic moderation condition, people talked more, people paused less, so there was more talking going on, less silence in the groups. The pause times within turns of speakers were also shorter, and the speaking rate was higher, so people were more active, they were talking more vividly. Look into the ideas, into the idea output, we see that there's a less chance to get basically fewer ideas. So the risk of ending up with only very few ideas about how to pack the egg is less, and we are also experts to rate how innovative are these ideas to pack the egg. And also there we see that in the charismatic moderation condition, the experts have rated the ideas as being more innovative, as being more original. And last thing, the people themselves also thought about themselves as being more capable, as more intelligent, as being well-mannered, reflective, sincere, unconventional in the charismatic voice as to the normal voice moderation condition. So even the people themselves in self-assessment questionnaire after the task thought that they actually are better. So that this is only based on 8.5 minutes of video-based moderation in 2 different workshop conditions. So I think this is actually quite amazing what each can do here. And one final thing is where we are currently active. This is also the reason why I'm here at Technical University Berlin. At least this is also one of the reasons why I'm here, is that we also have to make sure that we use the speech science knowledge properly in something like speech technology, especially when it comes to digital communication. There is still something like a charismatic gender gap in the way that female speakers, all else equal, are perceived to be less charismatic. It is not every time the case. It's not in all studies, not in all cultures the case, but the gap is basically still there. And especially if you ask people about, for example, investment willingness. So when it's not just about rating the speaker, but when I have to make a rating that basically concerns myself, that concerns my own money, my own time, my own willingness to invest, then we see that the female speakers are still rated less in terms of the charismatic performance or the charismatic effect than the males. And one of the interesting things is what you see here on the left-hand side, where we see what actually happens if we talk over, now, for example, over Zoom or in strongly compressed video calls, in strongly compressed mobile phone communication. How much do people lose? And what we see is that when it comes to being charming, credible, and persuasive, female speakers lose more in video calls or a mobile phone communication than the male speaker. So basically, speech compression algorithms treat female speakers worse the male speakers. And this is something where the speech sciences, I think, can also make a difference in the future. And the other thing where the speech sciences can make a difference is what you see on the right-hand side, where my PhD student, Emana Gutnick, has used the Pratt gender change function to convert male voice investor pitches into females and vice versa. So what you see here are the original male investor pitches, then the males who have been converted into females, and you see the original females and the females who have been converted into men. And we have asked for the expected success of the company in percent, and we have asked people, how much would you spend of your own money into the speaker's idea? And it's interesting that you see that if you are gender changing by means of Pratt, if you are gender changing a male voice into a female voice, more or less all else equal, except for the pitch level, of course, then we see that suddenly people are less willing to invest into the speaker. And if you take an original male voice, female voice, and make it male, then suddenly people are willing to invest more into the speaker. And the same is for the success. So people of males to be more successful, even if you are taking female voices and convert them into males, or they are getting less successful if you take male voices and convert them into females. So basically, we as speech scientists have to raise the awareness of this kind of gap, and we have to train people, or we have to make sure that we get this kind of gap closed, be it by political means, or be it by campaigns, or be it by training, especially female speakers, to become more charismatic, be more powerful. And what is currently going on in our lab, the current activities are that we are looking into hate speech. Claudia knows that. We have a hate speech project where we are looking into speech, and we are interested in how is hate speech perceived if we speak it out aloud. So do people perceive it as being worse, or as being even better than the actual written hate speech post? And they are interested in insights. So for example, that if there are keywords, if there are hateful words inside the post, then it gets definitely worse if you speak it out aloud. But if there are things like sarcasm, or if there are things like I have nothing against, but then things can actually even get less hateful if you speak them out aloud. And the project is actually aimed to to provide guidelines for societal and political decision makers. So we actually want to use our research to inform politicians and to inform companies like Facebook about how they can better assess what is hate speech and what is not hate speech. One more thing that we do currently is that we design mobile phones about the placement of loudspeakers and such that we reduce the kind of telephone voice effect to increase the comfort and the privacy of mobile phone communication. So we co-develop mobile phones or provide mobile phones casings such that people have a better comfort in talking and that they have more privacy in talking by basically not talking so loudly anymore. So we try to get the voice pitch levels down by changing the shape, the haptics of mobile phones. And the last thing we do that is perhaps one of the most interesting things actually is that we design musical instrument strings, or what we have found out is that people are basically, no, I have to say it differently, that one way to rate the sound quality of a musical string, for example, of a cello string, is that you take the cello string sound as a source signal in speech production. So you're basically taking out people's source signal and you're taking the musical instrument inside, and then let people rate speech and not just music. And if you do that, people have a much easier time, even the naive people, to rate the sound quality of musical strings. And it's also much clearer that there are cultural differences in preferences for the sound quality of musical strings emerge. So you can even use speech, basically, or speech science knowledge to inform musical string quality rating and sound quality design of musical instruments, culture specifically with companies. And this is all something that speech science can do. So the bottom line is that we as speech scientists, in my opinion at least, work on one of the most exciting, important signals in the world, and we can be proud that we have the knowledge to be able to inform so many areas of application, music and pain and charisma and whatever, sound design of actuators or of wheelchairs or whatever. We can help people making decisions in many everyday life situations, and I think this is what makes speech very special, that the way we are perceiving speech and the way we are thinking about speech is similar to the way we are thinking about all other sounds that we get. Sounds of machines, sounds of music, we all connect this to speech, and therefore speech is somehow the center, and understanding speech means also that we are able to inform basically many other disciplines. And I think this must be brought out more broadly to the public. And I think, yeah, this is basically the message of what I want to get across here with you. Again, many, many thanks for your attention. That was it.